Okay, an application of the common ion effect is that you get a buffered solution. What happens when you have a buffered solution is it resists pH. So when you have, let's look at our HF example. This is an acid. This is the conjugate base. So by having both of those, if you add H plus, it can react with the base. But if you add OH minus, it can react with the acid. A buffered solution essentially has acid and base already available to react with whatever you're added. So a very important practical application of a buffered solution is in your blood. Okay? You have carbonic acid, which separates into H2O and CO2, which of course CO2 you exhale. And then that separates into hydrogen ion and the carbonate ion. And so the exhaling CO2 helps maintain this, and your blood maintains a very narrow pH range of 7.35 to 7.45. So, to have a buffered solution, you need a weak acid, HF, one of my favorite examples, of course, and a salt containing its conjugate base. So, any weak acid and any salt with a conjugate base. And of course, we are usually going to have Na plus or K plus for the counter ion because of that always soluble characteristic of them. Now, of course, we could also have a weak base. For example, NH3 ammonia is a weak base, and so its conjugate acid is the ammonium ion. So a salt with the ammonium ion, that's the conjugate acid. And again, we want a soluble negative ion for this.